Okay, I'm going to do a quick video about splitting the positive. Now, somebody asked me about a microwave transformer. Actually, they didn't. They asked me about the core material. Alright. Now, it's time that somebody who knows about this a little bit shares with the people who don't know anything. Now, this is a microwave transformer. And this, well, this came all the way across. I don't know. I guess you can see it. Let me check my camera here. Yeah, you can see it. And I want to show you this too. See the chalkboard? That's splitting the positive. Let's go over that right quick. In order to, you see that motor? I don't know. You can't see where it's motor. Let me see. I don't know how this camera goes white and dark, but I like it there better. Yeah. See the waveforms at the top? Alright. You have a motor, a pulse motor. You see, you can take a magnet motor and pulse it. This is in the benzene or I don't know how to pronounce that patent, that darn Carlos. Anyway, he talks a lot about a lot of different things. And this we learned from Turion, Matt, and some other gentlemen who are already doing this on the energetic forum. But just because this says motor, remember that it needs to be pulsed. You have two batteries and a third, and the positives, both positives run the motor. So how is it connected? It's connected positive, well, normal here. This is 24 volts right here. That's 24 volts. Chalk's decided not to write. 24 volts here, these two batteries. And this is a 12 volt battery. My chalkboard is not writing, but I'll have to paint it again. Okay, so you can see that positive and negative are hooked normally. That's 24 volts. Then this negative is hooked to this negative. Now, isn't that interesting? That's different, isn't it? And so you hook the two negatives together, and that leaves a positive. But this positive is less positive than this positive. You see the two positives that are open? Because we got these batteries hooked kind of messed up, right? It's not normal. That's supposed to be over here, right? And then you'd have 36 volts. You could run your motor on 36 volts. And this is a rotor with magnets on it going round, and the generator coils are another subject altogether that go out here, and they make power. Now, I want to split the positive to drive my motor, and I want to use these coils to speed up this rotor. I want these coils wound, and have done it, as if they were not even there. It helps this motor. I can run this motor normal with a rotor and magnets on it, and it costs me 2 amps, 2,000 milliamps. That's what it cost me to run this motor. Now, my motor is not a pulse DC type. Well, I need to pulse my motor. Mine's an AC motor. Now, some people use magnet motors, and if this was like a scooter motor, you could pulse DC it. That's what you need to do. So there has to be a circuit here somewhere to pulse this right here. So this needs to be pulsing right here. This needs to be a switch here. And so we'll just make a mess there, but let you know that this is not just a motor running off the positives, although it would work pretty good. If you have the right motor, you need to pulse that motor. No, it won't work with just a regular motor, but if you pulse it, it works well. It keeps these batteries charged, and this battery gets charged anyway, because all the potential on 24 volts goes through this motor and really fills that one up. So you got an overfilling problem here if it's too small. Okay, so just a quick video. What I'm doing, and let me erase a little bit here. What I want to do is I want to use this same idea, and I'm running this by some of the guys that are way more advanced than I am. Let's move. I want to use a motor, but I want to use an AC motor. And instead of DC pulsing, I was thinking maybe I could use an SCR circuit, or I could use a triac circuit to mess with my waveforms. I could do pulses all above, or I could just hack off a little here and a little there like triac circuits do to get my pulses different, or might change my frequency and things. Those are the types of things going through my mind. But my plan is to use a simple dishwasher motor and use 4 batteries like this. 4 batteries in series like this, and then that's 48 volts right there. 48 volts. It's not 24 anymore, it's 48 volts. Now what that does is when I hook it to my inverter here, I'm going to have an inverter. This inverter will run this AC motor. Okay? Now let me check my camera and make sure you're seeing all this down here. I guess you're not quite seeing everything, huh? Don't want to get too far off the board and still get enough light to see what's going on. So now when I ran this inverter, which was a 12 volt off of just, some batteries, to run this AC motor at 120 volts, 120 volts at like, we'll say 2 amps or 3 amps, we'll say. That's 3 amps to start it up, and then it drops way off. Well, on a 12 volt battery, that's 30 amps. And I don't want to use 30 amps in my batteries. I want to use 48 volts so that I can use a lot less amps to my inverter. You follow me? And my 12 volt battery over here will be a big multiple parallel set of batteries over here that is negative here, and that negative is hooked to these negatives, and then and then this positive comes up over here to the inverter, and this positive goes to the inverter right here. Of course, this is much more positive than this. This is only 12 volts. So, 12 volts here and 48 there leaves me 36 volts. Now you can buy these grid type inverters we really got an advanced society now where our electronics is really moving along. So you can buy inverters that are 22 volts to 60 volt input, and anywhere in there that you want to put voltage in, it comes out 120 or it comes out 220, whichever you prefer or need. So in my case, 120, and if I put in 48 volt, well, 48 here and 12 there, and take away the differential, that's 36 volts going to my inverter, then I won't need 30 amps anymore. Now 120 times 3 is 360 watts to start that thing up. So 360 watts at 30 volts would be more like 10 amps I'm sorry, not 30 volts, 36 volts. 36 volts times 10 is 360 watts. So now my batteries can be smaller, because each one of these batteries could give me 10 amps easily. The ones that I have the big batteries for like the 3-wheel carts for people who are injured. And when you go to the Walmart, you'll see these batteries. Well, each one of those batteries connected in series like this, each one could provide, could run at 10 amps easily. And it might not be quite within the C20 rate, which is important, but it would make the test. Okay, so we got 36 volts and 10 amps finally coming, but we need to pulse it, and that's what I was saying. Let me go back here to the camera. We need to pulse that motor there and that inverter down below. So let me erase some of this now that you've seen that. But down here we want to pulse that. So why not, why couldn't we pulse it where the inverter, oops, we'll just erase the whole thing. Now we have our 3 battery system up here, and the leads are coming down, and I have an inverter that's being powered by 36 volts at 10 amps, and I have a motor over here with a flywheel on it with magnets. It's a rotor. So I need to pulse this, but this is AC. This is AC. Now this may not be the easiest and most optimal way to pulse, and to with all these conversions and whatever, you're gonna have losses either way. But I need to pulse that, and I see these cheap SCR circuits. Why not use an SCR circuit? I'm gonna try it, and then pulse the motor, because in that patent it's a requirement. If you have a DC motor, that's fine. You have DC pulses, real narrow if you like. But if you have an AC motor and you need to pulse it, you can use these, or you can shorten it. I don't know, I think the SCR circuits have variable frequency. Or you can use triacs, but they're a lot more expensive because they do fancy wave cutting like this. Or this is where the wave is powering and the rest of the time it's not. So that's something to think about. Okay, so now let's get off of that subject and go over here. Here is my microwave transformer. More in the practical, okay? Also, this is my Lazy Susan bearing that came in the mail right here. And I just put it on a board. I don't want it too slippery, so I bought a 6-inch. You probably can't see the bearings in there, but this is a big one. This is a 6-inch hole in there. And here's that broken spool. So we can put that spool on there. And then we'll have to center it up and get some kind of drag on it so that when it's spinning it doesn't just go boing all over and the wire comes off, right? And then it will go over and up and on my winder. So you can see it's pretty free. And you want to start with something that's a known amount of resistance. Even if you just want to put, you could just use milk jug high density polyethylene washers, big ones, and put under there because they would slip perfect every time. I just chose to do it this way. You got to get it where it's the same every time, and then you know, I'm about to show you what I'm going to wind it on this, right? This is a microwave transformer. It's made of all kinds of little leaflets pressed together with wax or whatever. But if you try to cut this center piece out like I did here, you're going to need to drill holes here. Now you'll notice that they already had a rivet in there from the factory, and I kind of messed this one up. I was just chop jobbing it, but it's still usable. It's tried to split, but when I've got a ton of these transformers out back, and I'm going to start making these coils. These cores. But somebody wanted to know how you made a core, and then I put the spool, up around it here, and put the protection here after I pulled the bolts out. But I bolted, basically I just bolted this and clamped it with vice grips. When I drill it, clamp it on each side or one side at a time and drill it, and then put your little teeny nut and bolt in and save your bolts for the next time. And then I took this. First of all, you have to know that this microwave transformer is like this, right? And it goes all the way across, and you got a lot of area there. But you have to grind this edge where the weld is. There's a weld on there, and you grind that off with a die grinder or a little tiny grinder on each side. One there and one there on a line all the way across, and then this comes off. And you'll notice there's welds. There's a weld there. Can't see it probably. There's a weld there. There's a weld. There's different welds on them to hold them together, just lightly welded from the factory. And so, to hold all these leaflets together. But when you start getting rowdy with it, you're going to need to when you start cutting this centerpiece out, which is very big, it's a large portion of the transformer, you're going to end up with this all splintering on you, and you're going to have to drill holes. Drill some holes. You can you can put a nail in it later